We're going to talk today about kinetics, and this is one factor that is important when we are considering reactions. So I want you to see this profile, reaction coordinates. See that this is my difference in get free energy. So we have learned about thermodynamics. Say that we have a reaction like that, and here you have reactants A, say A plus B, to give products C plus D, that. And we have talked about the composition of the equilibrium be depending on delta G, which is, say, the difference in get free energy here, your products, minus the reactants. So we are talking about this difference between these two, right? So that, and we also, what we're saying is, for example, in this particular profile, this reaction is exergonic, and that means that the products are more stable than the reactions, so the reaction is product favor. At the equilibrium, there is more products say than the reaction, and we have written already the equilibrium constant for that is, say, this expression. And we also talk about the, again, the thermodynamic factor, thermo is that. So thermodynamics is saying that products are more stable than reactants, that's that. Now, this is not the only factor that we need to take into consideration when we are studying reactions. Some reactions may be product favor, spontaneous, which is like this process, product favor, and still be very slow. So rates matter. So we're going to be talking about reaction rates. And rates now depend on many factors. One of them, for example, concentration. We can write, let's write an equation on rates. And that you have seen in your general chemistry rates. For example, for a reaction like that, A plus B should give C and D, as we have here in that expression. We can say, for example, that the rate will depend on the concentration. That's one possible rate law, depending on the concentrations of both A and B. And we say also that this reaction is order 1 in A and order 1 in B, total order 2. So rates depend on concentration of reactant, but also depend on temperature and depend on one very important factor, which is called the energy of activation, which is this threshold. Say that you need to jump, molecules need to come off here over this barrier to react and make products. And the smaller this is, the faster the reaction. That's it, essentially. So in the greater the energy of activation, the slower the reaction. We can also say that the relationship between the rate and the gift-free energy, the change in energy of activation, we could say this is E energy of activation over RT. In other words, we can estimate this knowing the barrier, or we can measure rates in determining the energy of activation. There's a number of things that we can do, saying, taking, for example, log and doing plots. But that's not the idea here. What I want you to focus is that we have two factors, thermodynamics and we have kinetics. So the two things play a role. And when you're talking about thermodynamics, you are talking the position of the equilibrium, and that depends on the difference in energy between reactants and products. And when you're talking about rates, this is where you are, it's going to be important for you, this difference between reactants and the transition state of the rate determining step if you have several steps. So we're going to be doing more of that in another video. I'm going to draw, say, for example, other profiles having more than one step and identifying different points in the curve.